Welcome. In this short video, I'm going to review tests of difference or how to compare groups that we covered during class. So there's several statistical measures of difference that would allow you to compare groups, and the nature of your data. So whether you have variables that are nominal, ordinal, interval, or ratio, and your research question will dictate which measure you use. Today we're going to focus on t-tests, and we'll briefly talk about ANOVAs. There are two main types of t-tests, that you will most likely encounter. The first one is an independent samples t-test, and that's where you want to compare the mean score, the average, the score. So we're talking about a continuous variable, or a variable that is at the ratio level of two different groups of people or two different conditions. Okay, so for example, I might want to be interested in looking at, is there a difference in SAT score for students who had an IEP plan in high school versus students who did not have an IEP plan in high school. The other type of t-test that's fairly common is a paired samples t-test. And that t-test is when you want to compare the mean scores for the same group of people at two different occasions. So for example, I might want to compare the score of someone's ACT score before and after they take a $5,000 prep class. So same group of people, it's just their ACT score before they take the very expensive prep class, and then their ACT score or SAT score after they take the very expensive prep class. In both of these examples, you are going to need one continuous dependent variable, so that score, and one categorical independent variable, so that is, in this case, dichotomous. So in the independent samples, I had the dichotomy of people who had an IEP plan in high school and people who didn't. In the paired samples, I have the dichotomy of before the prep class and after the prep class. Given the data set that we are using in this class, which of these tests do you think we should use? And so I'll pause briefly, and then just very quickly, the data set that we're using in class only captures people at one moment in time, and so we don't really have a before or after. So we really can't do a paired samples t-test because we don't have the data to do so. So we're going to look at an independent samples t-test for class today. There are some assumptions you need to meet associated with tests of difference, and I'm going to briefly just kind of cover these. So we're going to assume that your data are coming from a random sample of the population. This is not always the case, but it is something that you kind of want to pay attention to. Your observations are independent of one another. So, for example, if I was going to be looking at measuring students, their test scores, if they're all working in a group together, well, that's actually not really independent of each other because each member of the group actually influences the people around them. You want to make sure that you have a large enough sample size, and for the purposes of this, I'm going to say probably at least 30 people per cell. Now, our data set is fairly large, so we don't really actually have to worry about this, but that's something you're going to want to consider when you look at your dissertation. And the conversation about power is not one that I'm going to include within the scope of this video. Missing data, so you're going to want to make sure that you address that. One of the assumptions underlying a t-test is that your variables are, at least your continuous variable is normally distributed. I'm going to ask you to look at that later. In real life, this might not be, and sometimes t-tests are fairly robust, but it is something we want to take into consideration. Homogeneity of variance. So the variables for each score of the group need to be similar to each other. And there's actually a test in the t-test, that Levene's test, that will look at this for you. What's important here is that you want your Levene's test to be not significant, which is bigger than 0.05. And then effect size. And so you may get a statistically significant difference, but that really doesn't tell you about the strength of the association. And so an effect size is a measure that's going to tell you or indicate the magnitude of the difference between your groups. So this is fairly important if you do find statistically significant results, and it is something you would need to report out. It's also basically a way to tell if your results are practically significant, or give a better sense of the meaning of that statistical significance. So we have a bunch of different tests of difference. We are, in this video, going to focus on an independent samples t-test because we have two groups that I'm interested in. If I had 3 or more groups that I'd be interested in, then you would potentially run an ANOVA, and that's a different video. Alright, so the question that I have for you guys today is there a difference in EdTest score between students who have an IEP plan in K-12 education and those who do not? The steps that I would like you to walk through for this, you are going to need to examine on your own the variable of have an IEP plan in K-12 and the variable of EdTest score. And so I want you to do that by looking at the descriptive statistics for those two variables, doing the appropriate measure of central tendency, the appropriate measure of variance, and running a histogram. I'm going to pause the video at this point so that you are able to do that. And then when you've done that, please come back. Alright, welcome back. So, in getting started on a independent samples t-test, the first thing that you're going to do is go to Analyze and then Compare Means. And then we're doing an independent samples t-test, so we'll select that. Okay? You're going to move your, let me scroll to the bottom here because that's where my variables are, all the way to the bottom. You are going to move your dependent, or the continuous variable, into the test variables box. So the dependent variable in my question was EdTest score. Move that over. And then you're going to move your independent, or in this case, categorical variable, into the grouping variables box. And the one that I'm looking at is whether or not a student had an IEP or not. So I'll move that over. Then you're going to want to define the groups for that particular grouping variable. And so you might want to make sure that you just click on that and highlight it, hit Define Groups. And in this case, we know that 1 is does not have an IEP plan and 2 does. If you were ever confused about that, you can always just go to your variable view and click on the little dots. Then you're going to hit Continue. If you were interested, you could hit Options, and then this is how you might deal with missing data. For these two variables, I've actually removed the missing data, so we don't need to worry about that. Hit Close, and then I'm going to have you go ahead and hit Paste, because I'd like you to get in the good practice of running a syntax. So we'll hit Paste. Up comes your syntax. You're going to highlight that syntax, hit the green Run button, and then your output should show up very shortly. I'm going to pause the video while the SPSS thinks, and I'll come back when I've got some output. Alright, so this is what your output looks like. And in the box here we can see that 1 was no and 2 is yes. We have about 23,000 students in this data set that did not have an IEP plan, and about 9,400 that did. Their average, their mean EdTest score, is approximately the same. So for no's, the average EdTest score is 49.99. And for yeses, it's about 50.03. And so this leads me to think that right off the bat, there's probably not going to be statistically significant differences between these two groups. But I'm going to continue on. For those who are interested in the standard deviation, or the variation in the two groups, again, 4.9 and 4.9, so we're pretty closely similar in that capacity as well. When we're interpreting the independent samples t-test, the first thing you're going to want to do is check the underlying assumptions. And so the first test, or the first underlying assumption that we're going to look at is Levene's test for equality of variance. And that's going to be right here, Levene's test. Your test statistic for that is F, and your significance level is right here. And keep in mind that you want the significance level to be greater than 0.05 on this particular test. Since the outcome of this test is going to determine which of the two t-values over here you're going to use. Now in our particular example, the t-values are the same. But since we have not violated the Levene's assumption, we are greater than 0.05, we're going to use the top row for the t-test. Okay? If we did violate that, so say it was 0.03, and then we could not assume that our variances are equal, then we would, or the equality of variances is not assumed, then we'd use the bottom row. But again, in this example, they're the same. So we'll be using the top row for our test. And if we move over, this is the significance test for our t-test. So we see that we are 0.538. That is much larger than our set p-value for this, which would be 0.05, meaning that our results are not statistically significant. Generally, I think that we would probably pause at this point because you're like, oh, those are not statistically significant. But I want to use this as an example to talk through other things that you would consider. So in particular, effect size. Effect size is one of the very few things that SPSS does not calculate for you. But if you are going to run a t-test, it is something that you need to calculate and report. The effect size is essentially the indication of magnitude of the differences between your groups. All right? So yes, there is a difference. That's what the t-test tells us. And then the effect size is going to give us a sense of how much difference there is. There are two very common options for effect size. One is eta squared and one is Cohen d. And Palint's chapter on t-test, I think page 251, is going to talk more about this for you and give you some links to websites in which you could go calculate those on your own or walk you through how to hand calculate them. The one I want to talk about a little bit is eta squared. Eta squared is going to range from 0 to 1, and it basically represents the proportion of variance in the dependent variable, so in this case in ed test score, that is explained by the independent variable or the groups, so having an IEP plan or not. The guidelines, if you're interpreting your effect size as an eta squared, 0.01 is a 0.01 is a small effect, 0.06 is a moderate effect, and 0.14 or larger is a large effect. Okay? If you're going to calculate out Cohen's d as an effect size, this is a slightly different calculation. Please read Palint page 251 and on, and some of the other resources that author lists, as you'll find those useful. So this is essentially an overview of the independent samples t-test that we covered in class. Please let me know if you have any questions.